Hey everybody, it's Mr. Carr again. Today we're going to be talking about 9B Day 2, solving quadratics using radicals. Okay, so when we use quadratics to solve radicals, we're going to do a lot of what we did yesterday's lesson. Okay, the goal here is to we're going to be taking the square root of things, and that's why we kind of practice with that and simplifying our radicals. Okay, so today we're going to do what's called the square root method. This is our process, okay, process of undoing something squared. I don't want to say something. Let's say a value squared. Okay, so the examples we might use that is we use this method when the quadratic looks like x squared or x plus something squared. And it's like plus or minus something squared. So what I mean by that is it's just an x squared or the x plus something in parentheses squared. There's no like standard form where it's x squared plus 5x plus 10. The 5x means we cannot do the square root method. Okay, now the reason the square root method works is what's called the square root property. To solve a quadratic equation in this form of x squared equals n, we simply just take the square root of both sides. Okay, so it looks like this. If x squared equals n, we take square root here and square root here. We end up with this. Now, a couple things to show. This is the symbol plus or minus. That's how I read it. So x equals plus or minus the square root of n. The reason we use the plus or minus is just because we do the square root property. We have two answers from this. We have a positive version and we have a negative version. Okay. So we get the plus or minus because we have two possibilities from that problem. Okay, so for example, let's look at x squared equals 121. The goal here is I want to undo the x squared by doing the square root. 121 is a perfect square, so actually I get two answers, plus or minus 11. That's a nice and easy one. If I was looking at the graph of this, the reason why I got plus or minus is because I have two answers like that. I'm going to pause it real quick for this all. All right, now that that's over. So yeah, we get two answers. We get a positive 11, 0. We also have a negative 11, 0. These are the 2 points that the graph would cross if I can try to graph y equals x squared. Okay, so m squared equals 56. Again, the square root property says if I have m squared, I can undo that with the square root. However, 56 does not have a perfect square root. So we're going to do like we did in the previous lesson. Let's break that down. If I think of two numbers that multiply to 56, that's 8 times 7. 8 is made up of 4 times 2, and then 7 carries down. And then 4 is made up of 2 times 2, and then a 2 and a 7 there. Again, the goal yesterday was, can we simplify with a pair like that? So the pair of 2's is going to come out. I'm going to have a 2. 2 and 7 don't have any pairs with there, so we're going to multiply those back together to make 14. So my answer here is a plus or minus 2 square root of 14. Okay, now that's only if I deal with the answers that are not perfect squares. Like example C and D are both perfect squares here. So if I look at this one, x minus 7 squared equals 36. When I solve this, I'm just going to, like in this format, I still have this expression squared. So I can take the square root of that whole thing. When I do that, I get x minus 7 as that answer. On the other side, I'm going to have plus or minus 6. Well, if I think back to my other solving processes, I got to get rid of the negative 7. To do that, I'm going to add 7 to both sides. So I'm going to kind of do it right here, but here's what is really happening. It's going to be 7 plus or minus 6. That means I'm doing two things, okay? So I'm going to do x is equal to 7 plus 6. So my first x value is 13. Then I'm going to do the second one. I'm going to do x is equal to 7 minus 6, which gives me 1. There's my two answers, 13 and 1. Okay, so that's what happens with these types of problems. So D is going to be the same way. If I square root both sides right away, I'm going to get x plus 9 equals the plus or minus 8. Subtract 9 to both sides. So x is equal to a negative 9 plus or minus 8. Again, that splits off into two possibilities. So I've got first possibility will be negative 9 plus 8. So that gives me x equals a negative 1. The second possibility is going to be x equals -9 minus 8, which is a -17. Okay. After that, we're just going to add more steps into the process. Now, the key here is we have to have it as like a parentheses squared equals a number or x squared equals a number. So when I look at this problem here, we have 4x squared minus 10. I cannot take the square root yet. Okay, so instead, I'm going to like do my process of undoing these other steps first. So think of it this way. If I think about my order of operations, so like x was a number, the first thing I would do is that I would take it to the second power. So that's my first operation. The second thing I would do is multiply. The third thing I would do is subtract 10. So I'm going to undo those steps in the reverse order, which means I'm going to add 10 to both sides. So 4x squared is equal to 100. Now I'm going to undo the times 4. So I'm going to divide both sides by 4. So x squared is equal to 25. And then I'm going to undo the squared by doing the square root. So x equals a plus or minus 5. Okay, so that's another way, when these get more complicated, that's another way of thinking of this. I'm undoing my order of operations. So for example F, this is my first operation. I would subtract. Then I would square it. Then I would add 8. So reverse that order. Get rid of the 8 by subtracting 8 to both sides. So x minus 1 squared is equal to 24 minus 8, giving me 16. I undo the expression squared by doing the square root to both sides. So x minus 1 equals the plus or minus 4. Then I'm going to add 1 to both sides to undo this subtraction. So x is equal to 1 plus or minus 4. And I'm going to do 2 operations, okay? I'm not going to split them up and write them that way, but I am going to go both. So I'm going to do 1 plus 4 first. So I get a positive 5, okay? Then 1 minus 4 gives me a -3. Okay, so the rest of these are just more examples of that. So I'll run through these 4 a little bit quicker, and just so you can see everything there. Again, I'm going to focus on the order of operations and undoing that. So again, first thing is that I do inside parentheses is that right there. Then I would do exponents. Then I would multiply. Then I would add. So it goes 1, 2, 3, 4. So I'm going to undo the fourth, undo the third, undo the second, undo the first. I'm going to reverse the order when I solve this. So we'll start by subtracting. 4 times x minus 9 squared is equal to 16 minus 12 is 4. Then I can divide both sides by 4 now. So I get x minus 9 squared is equal to 1. We square root both sides. So I'm going to rewrite it up here. So x minus 9 is equal to a plus or minus 1. Then add 9 to both sides. So I get x equals 9 plus or minus 1. So I run through that twice. 9 plus 1, I'm going to get 10. 9 minus 1, I get 8. Okay. H, we have addition, squaring, multiplication, subtraction. So I'm going to start with addition here. So -3 times x plus 10 squared is equal to 675. Divide both sides by a -3. So that gives me x plus 10 squared is equal to a -15. No, sorry, -25. Then I'm going to square root that, but here's something we didn't talk about before. What happens if I take the square root of a negative number? I can't do it. Okay, because remember what a square root says. I'm saying a number times itself gives me -25. If I take positive times positive, I get a positive number. If I take 2 negatives multiplied together, I get a positive number. So my answer here is actually no solution. Okay, and that's as far as I can go with that one. Once I am taking the square root of a negative number, that's an impossible thing. So we're done. Okay, so just be aware of that as you work through some of these other problems. The next example is a good one because we can take the square root of, we take the square root of a positive, cannot take the square root of negative. In this problem, if I subtract 18 to both sides, I get x minus 11 squared equals 0. I can take the square root of 0. That's okay. So I do that, I get x minus 11, but there's no positive or negative version of 0. So it's just 0. So here's a scenario where I get a single answer. Okay. x equal to 11, and that's it. There's nothing else to say with that one. Okay, last one is j here. So again, we are squaring it. So that's the first, then multiplying, then adding. So I'm going to start off by subtracting the both sides. So negative 5x squared equals a negative 125. We can divide both sides by negative 5. This one is going to come out okay because negative 125 divided by negative 5 gives me positive 25. Negative divided by negative is still positive. So now I can still take the square root there. So x equals a plus or minus 5. Okay, and that's it. Okay, so again, the whole idea of square root property, we use it to undo something that's squared. All right, and that's what we see in all these cases. Now, when I do that, it's either got to be like this, where it's inside of an algebra expression, or this, where it's an x squared. Okay, and the other part of my message today, we are undoing order of operations, just like we did way back in unit 2. So when you do that undoing order of operations, I kind of list them out like this, where I do parentheses, or sorry, let's look at here. It's parentheses, exponents, multiplication, addition. So I reverse that, I do subtraction, division, square root, addition again. Okay, all right, that's it for today. Take care.